Gauss-Jordan elimination is such a useful technique for solving systems of equations that it's been implemented on a lot of software packages like spreadsheet software, as well as on graphing calculators. So let's use this video to illustrate how you could use a graphing calculator to perform these steps automatically. The key idea is going to be just to translate the system of equations into a matrix form and then use the features of the calculator to perform elimination for us. So let's take a look at how a TI-84 can be used to perform this. The first thing we want to do is enter a matrix. So on the graphing calculator, you can see that the matrix feature is here above the fourth button in the first column on the main set of keys. So to get that feature, the matrix feature, I need to hit second matrix. Now I need to start by editing the matrix. So I'm going to pick the edit menu. And let's just use the first matrix here, the matrix A. So I'll click enter. And now this brings me to a screen where I'm able to tell the calculator what the values are that I want inside my matrix. The first thing I have to do is tell it the dimensions of my matrix. Now if you take a look at the system of equations we're going to solve, there are two equations, so that means the matrix representation will have two rows. So I'll type 2 and then press enter. And then there are two variables. Each variable becomes a column of our matrix, and then there's also a third column for the constants on the other side of the equal sign. So we need 3 columns. I'll therefore press 3, enter. So I've told the calculator that I want a 2 by 3 matrix, and it gives me a 2 by 3 matrix, and I just have to edit the values that are in that matrix to make them match up with what I want. Now if we take a look at our system of equations, I want the first row to represent the first equation. My first entry should be the coefficient of x, which is a 1. I'll type 1 and press enter, and that stores the value 1 in that entry for the matrix. Then I want a 3 and a 5. The second row will be 2, 1, 0. And so the matrix you can see on the screen here, 1, 3, 5 in the first row, 2, 1, 0 in the second row, corresponds to the matrix representation of the system of equations. Okay, now I've entered the matrix, I can quit from that screen. Quit is above the mode key here, so to get that I need to hit second quit. And now I want to perform an operation on the matrix. So to get the operations for doing calculations on matrices, I have to go back to the matrix menu, second matrix. And now I want to pick something. I'm going to do math on the matrix. I need to pick something from the math submenu. And the feature we're looking for is called RREF, for reduced row echelon form. I'm going to select that, and that's an operation that can be applied to a matrix. Now I have to tell the calculator what matrix to apply that operation to. Well, we just stored the matrix we're using as the matrix A. So if I go back to the matrix menu, the first screen that pops up has the matrices that we've already stored and their names. So I want to use the name of the matrix A. That's the first item on the list. It's already highlighted, so I can just hit enter. Or since it's the first item on the list, I can hit the number 1. Either way, that inserts the name of the matrix A inside my function, RREF. This first parenthesis begins the operation. I need to give it a matching close parenthesis. And I'm ready to evaluate that operation. So I hit enter, and it tells me the result of Gauss-Jordan elimination. This is exactly the matrix we would get by making the left side of our original matrix look like an identity after performing elimination steps. And if you recognize the form here of this matrix, the first row represents an equation. X equals -1. The second row represents an equation, y equals 2. So Those are exactly the values we got by solving this system by hand. So let's take a look at another example. This time we'll use a 3 by 3 matrix. So again, I want to enter the matrix I'm going to use. This time let's use matrix B, so I don't have to write over A. But what I actually want to do is edit that matrix, so I have to go over to the Edit menu and then pick matrix B. This matrix will have 3 rows and 4 columns, and the entries are the coefficients from left to right. The coefficients are 1, 1, 1, 4 in the first row, 2, 3, 3, 11 in the second row, 4, 4, -1, 1 in the last row. After entering those, I can quit from that screen. And now I want to use Gauss-Jordan elimination, so that's the RREF function. I have to go to the matrix screen and the math menu to go find RREF. Be careful not to use REF. That's a different feature. You want the one with 2 R's. RREF, and this time I'm using the matrix B, so I'm going to select the second item from the names of the matrices list. That gives me matrix B. Close the matching parenthesis, hit enter, and voila, we get a solution. From this system, we can read the values. X is 1, Y is 0, Z is 3.